This demo refers to a multi-group analysis. So I will consider this model, and I will assume the data for this model was collected in 2 countries, and I have 2 variables that store data about the countries that I can choose from. I have this indicator country unstandardized, which stores the values 1 and 2. 1 is for Brazil, 2 for the United States. And I also have a data label variable that stores the name of the country, Brazil and United States. So I'm going to go to the option Explore Multi-Group Analysis. I would choose as grouping variable type label, country, and I'll choose the analysis method. Constraint latent growth tends to not segment too much the data set. Saturation weight and pool standard errors are more widely used methods for multi-group analysis, and they segment the data set even more than constraint latent growth. Therefore, constraint latent growth would probably be a better approach for this type of analysis. So I'm going to choose constraint latent growth, and I get the following results. The groups analyzed, Brazil and New Zealand, the ends for each group, 150. Selected outputs for each analysis, the path coefficients, focal linearity, VIFs. These are important because sometimes the segmentation of the data set for multi-group analysis leads to massive collinearity, particularly when the N for that particular data segment is very low. This is not the case here, and constraint latent growth is not as influenced by these variations in these across groups as the other methods are. And then the software provides the results for each pair. So in this case I have Brazil and USA only, just one pair. So these are the latent growth coefficients, and they are not, when we use a one-tailed test, they are not significantly different. This one gets close to being significantly different, but it's not. I also have p-values two-tailed. This is if I'm testing the assumption that there is no difference between the 2 groups. I also have t-ratios and confidence intervals if I want to use them for my test. If I choose Saturation weight or pooled standard error, I get similar results. With the difference that with constrained latent growth, I would have latent growth coefficients listed here. With Saturation weight and pooled standard error, I have path coefficient differences, and those are the ones that are compared and p-values calculated. And here, as it happens, pooled standard error suggests that there is a significant difference at one-tailed basis. This concludes this demo.